Hi everyone, I am Priyanka, Assistant Professor, Department of Computer Science, Christ College Autonomous, Iranyalakuda. Theory of computation is a different subject because it deals with both mathematics and computer science. So, this makes theory of computation a different subject in the field of computer science. What was the need of the computer? I will say to represent mathematical problems in a very easy and efficient manner. This was the invention that led to computer. That is, mathematician has faced a problem to do very complex mathematic problems in a efficient manner. So they developed a machine. One of such machine was the computer which hit the world. So theory of computation deals with that concept. How mathematical notation can be represented in a computer so that it can be done in a very easy manner. Now, computer science deals with not only mathematical notation but also electronics, biological, all notation. Theory of computation first need was the mathematical notation, but gradually it developed patterns so that any problem in the world can be mapped to computer science. That mapping is done by theory of computation, or its theories will guide you how you can do anything computationally. Before going into the theoretical concepts, it needs some mathematical notation or mathematical pre-knowledge background. We will see one by one. First one is the set. So now we are going to explain the set. A set is a well-defined collection of objects. What do you mean by object? Anything which can be picked, which can be filled, which can be represented as an object in computer science. Well-defined collection means no duplication. Means that it will deal with only unique values. There is no duplication will be taking. Okay. For example, A is equal to set 1 comma 2 comma 3. This is a finite set. If I put etc here, it is an infinite set. But I cannot put 3 here because well defined means no duplication, correct, perfect values, that is a set. Another concept I am saying is that I will first write and then say, that is, name of the set or the set itself is represented by the capital letters, and members or individual objects are represented by the small letters. This is in the case of alphabet only. When you are using alphabet, members will be small letter and name will be capital letters. Also, elements of the set are members or the objects of the set, or the objects are also called members of the set. Okay, this is the basic knowledge of sets. Next, we can say different ways of describing the set. First one, we have already seen that. What is it? It is listing the property, listing the elements. For example, I want to represent natural number less than 5. I will list it, pick one by one. But as you all know, this is not a practical concept. Practically, we cannot represent, we can't say. It is a less efficient method because practically the set will contains thousands or ten thousands of value which cannot be listed one by one. So another method come, that is listing the properties of the elements of the set. For example, here I define set X such that X is a natural number less than 5. I am describing it as a rule to 5. I am describing it as a rule. Okay, this is called the set builder form, and first one is called the roster form. First one, we are listing the elements one by one. Here we are describing the rules in a sentence, in a phrase manner we are representing. So it's more efficient method compared to roster form because we can represent any infinite value through the rules. Next one is the most important, as in the case of theory of computation, we are representing it as a recursion. Recursion means we already studied in C, that is calling by itself. We are calling and again calling. That is, yeah, we are defining X such that X0 is equal to 1, comma, xi is equal to xi plus 1, comma, xi less than 5, less than or equal to 5. That is correct. Okay, here we are defining recursively. First we define our begin condition, that is first number should be 1. Next we are recursively defining that first number we are taking plus number, next number we are taking plus 1. We are recursively defining it, calling first xi plus 1, next xi plus 1, next xi. That is recursively we are calling, and end condition must be set, that is xi less than 5. If it is an infinite set, no end condition, only starting condition or recurrence relation or recursive condition should be given. Okay, hope you all understand about the first one is the roster form, that is listing the element. Second one is the set builder form, writing the rule. Third one is our method, that is recursion, our or computer science method, that is recursion. Okay, next one is the subset. What do you mean by the subset? Okay, before going into the theory, I will explain that A is equal to set 1 comma 2, B is equal to set 1 comma 2 comma 3. Then A can be the subset of B. What does it mean? If A is the subset of B, A must contain all elements that B contains, nothing more than that. For example, if A contains 5, then A contain one element more than B, then A is not a subset of B. That is, A must contain exactly the elements of B, nothing more than that. Then A is subset to be the subset of B. That is, A contains all element that B contains, but B contains more element that A contains. So B is the superset and A is the subset. And next one is the equal set. Equal set comes if A contains same number of A and B contains same elements and same number of elements, then A is equal to B. Also, in equal set concept, A is the subset of B and B is the subset of A. Both are subset either or subset, then it is called the equal set. Okay. Next we can say about the operations on sets. For that I will define A is equal to set 1 comma 2, B is equal to set 3 comma 4. Okay, then what you mean by A union B? A union B means or means what? A union B set will contain both the elements of A and also the elements of B. Both members it will contain. So both members, first one is 1, second one is 2. Here 2 is contained. We cannot write 2 here because repetition is not allowed. So this is A union B. So what is A intersection B? Intersection, I am writing it as a cap, but it's like Malayalam alphabet Ra. Okay, what is A intersection B? A intersection B means intersection means the common elements. What is the common element here? 2. That is A intersection is the AND condition. AND means it contains the common elements. That means if A intersection B contains 2, it is in A and also in B. That is A intersection B contains the elements which are both in A and in B. Okay, that is A intersection B. What do you mean by A minus B or set difference? Set difference means A minus B means element in A but not in B. 1 is the first element which is not in B, so we can write here 1 here, but we cannot write 2 here because 2 is in B also. What is the definition? A minus B means element in A but not B. Right here. Okay. Next one is the complement concept. For that I define a universal set. Universal set means that all the set superset is called the universe. All elements will be in the universal set. A complement means element in A but not in universal set. So here the element will be there but not in universal set. That is called what? Complement. A complement means not in A. The element which A does not contain. That is set 3. Okay. Next is the power set. Power set means P of power set means set of all subset is called the power set. So null set is a subset because if I define null set here, null set is also element of what? A. Example, if B is equal to B is the subset of A because null set is the subset of every element. Okay, every element, not set. Next is a subset with one element. 1 is a subset of A. Set 2 is the subset of A. Set 1 comma 2 the subset of A. Subset means all the combination of power set means all the combination of the subset. Okay, next I will define a formula here, that is P of A is equal to 2 power n. Earlier we have seen power set of two elements, that is 1 comma 2 has four elements. So I will define how it become 4. 2 raised to set A contains two elements, 2 raised to 2 equal to what? 4. So to memorize the earlier example there, a power set of A contains what? 4 elements. Null set, set 1, set 2 and set 1 comma 2. Okay. If power set, if number of elements of the set is 3, then power set contains 8. If it is 0, 0 means what? Null set. Null set has, power set has one element, that is the null set itself. If set has null set, its power set contain only one element, that is the null set itself. Okay, that is about the power set. Next is the A cross B. A cross B, I am representing it as star because in my keyboard there is no cross here. That set B. A is equal to 1 comma 2, B is equal to 4. So what is A cross B? A cross B is defined by an ordered pair such that first element from A and second element from B. So first element I take 1, second element from B, 3 or 4 can be taken, taking in order only. And next one, first element from A, second element from B. You can take it in any order, but it must contain one element from A. That is, if A cross B, first element must be A's element and second one will be B's element. The order is important. A cross B, first from A, then from B. B cross A, first from B, then from A. Okay, can complete it. Next comes 2 comma 3. Say parallelly with my lectures what is the along with me. Also you write down your lecture notes along with me and with my lectures, then only you will get the clear idea about it. Okay, these are the, also I have already said A cross B is not equal to B cross A because the order is different. A cross B we are taking first A then B, B cross A first B then A. Okay, we can see the definition. A cross B is defined as A comma B, A from A, B from B, element of A and B, element of B, and A comma B is different from B comma A. Next one is the last topic, that is operation of the set. It is the last topic in set. It is a very important topic and you must be very clear how it is set. Okay. For example, I am writing set S, capital set S is equal to 1 comma 2 comma 3 4, and this is called the parent set, and I am writing the baby set. Baby set, this letter or the alphabet must be same for all baby set, but the number must be different. For example, if I am taking A as the alphabet for the partition sets, then I can write only in any partition A1, A2, etc. If I am using B, B1, B2, etc. I am writing A is equal to set 1 comma 2, A2 is equal to 3 comma 4, So this is one type partition. It's important that when we are taking partition, first condition is that alphabets must be same but indexes or the numbers must be different. Okay. Next one is that when we are taking a partition, partitions intersection must be null set. If you are making two partitions intersection, A1 intersection A2, no elements common, so it will be a null set. If I have two here, then it will not become a partition because A1 intersection A2 must be a null set. Also, next condition is most important. I must take all elements of the parent set if I am partitioning. That is more clearly, if I make a baby set, the baby set must be arranged in such a way that, or taken in such a way that it must take all elements of the partition set. You will have a little bit confusing the definition or my wording. For example, if in A1 I can take 1 3 or 1 4 I can take, but what I am saying is that if I take 1 2 here and 3 4 here, if I am not taking 4, then this is not a partition because in any baby set the elements of S must be coming. Okay, that is every element of S must be present or element of any one baby set. Okay, now I think you may become clear. Every element of set S must be a element of any baby sets or partition set. Okay, that is the second condition, that is A1 union A2 must be the set S. That means that when we again join these partitions, we get the original set. Okay. Okay. That is S be the superset and A the collection of sets. A means baby set. It can have A1, A2, etc. An subset. When it will become partition, any two sets or partitions intersection, we are randomly taking any two set, or you can check for whole set, it will become 5. That is AI intersection AJ, we are randomly choosing any two set, and we repeat it for the whole sets, whole partition we will repeat, and its intersection is equal to 5, and when we take union of it, it must be a set S. For example, here I take 1, 2, 3, etc. 10. Then I made two partition. Okay. This is the partition of set. By this, I am winding my topic, the set. It is a very easy concept. You have already studied some of the concept in +1 syllabus. Only something are different. That is recursion is different. You have not been studied. Partition is also a new thing here. But if you are having any doubts or does not have any idea uh, about the set, clearly watch my examples, also understand the way that I have said, and practice or memorize the way like that which I have said. That is important because I am saying it in the practical manner. If you have any misconcept in the earlier way you have studied, this is the correct way, that is not the correct way. So understand the way that I have taught you and understand it like that only, then only you will getting or mastering this subject, otherwise you will be misconfused. If you have any queries, you can ask me, I will clear it. But you must understand the set in such a way that I have taught you, and there are more concept in set. than I have taught you, but this is only thing you have needed in this subject. That preliminary knowledge I am only imparting to you. So set and max, it's a vast subject. I am not going into the detail. What you wanted that I am explaining. So stick on to it. Also avoid the misconceptions. If you have already studied it or mastered it in different way, avoid that misconceptions and think like what I have taught. Earlier also I have said any doubts you can query me or you can ask me. So be happy. Thank you. I'm stopping my lecture. We can see in next lecture. Okay, thank you. Thank you.